So yes, my name is Twan Korthorst and I work for Synopsys. And like Vladek mentioned, I was formerly with Phoenix Software that got acquired in 2018. And we got acquired by Synopsys, which is the #1 supplier of electronic design automation tools and services. And this slide actually I made before we announced our full fiscal year 20 results. And I believe these were about 3.6, 3.7 billion US dollars, and where we're targeting to continue to grow. And we do that from silicon to software. So we support foundries, we support integrated, vertically integrated semiconductor companies, and we support design houses and system suppliers with tools, with services, with a large IP portfolio for building blocks for physical interfaces, but also for analog and embedded memories. And then in addition, we supply a software security platform where software development companies can validate their software layer that they're either building on top of advanced silicon or to address also, let's say, enterprise solutions. And we do that with almost 15,000 employees around the globe, with about 130 offices. So then about photonics and optics. So Synopsys, as traditionally being from the electronic space, started acquiring and integrating and innovating in the field of optics and photonics, with products for cameras, for AR, VR, for automotive illumination, LiDAR sensing. So this is mainly about free space optics, where you use so-called ray tracing techniques. And in addition, more towards nanophotonics, integrated photonics, photonics devices like modulators, photodetectors, lasers, where we bring together the portfolio from RSoft Design and Phoenix Software. And today, we count that we have the largest dedicated optics and photonics software development and support team in the industry. So having said that as an introduction, our prime focus today within Synopsys Photonic Solutions is to support the optical communications technology roadmap, where the whole data communication is moving from gigabytes per second to terabytes per second, where the level of integration of the photonics and the electronics is increasing, where the complexity of the designs is increasing, and where a lot of industry activity is around co-packaged optics and really bringing electrical and optical functions together in one single form factor or package. So if we look at our tools that we map onto these timelines and these products, then we target we support customers with passive and active photonic device simulation with Centaurus TCAD and the RSoft photonic device tools. We have photonic layout synthesis with OptoDesigner. With OpSim circuit, we are able to support electro-optical circuit simulation. And with IC Validator, we have photonic design rule checking and LVS capabilities. And earlier in the year, we announced and released OptoCompiler, which is a unified electronic and photonic design platform. And to support the Datacom technology roadmap, we're also working on multi-die routing and thermal analysis of 3D IC and co-packaged optics constructs. And we supply IP for very short distance SerDes. So this talk will mainly focus on OptoCompiler, the unified electronic photonic platform that we launched on September 9th. And this is built on proven photonic technology that we acquired as Synopsys, and we further integrated and innovated on trusted electrical design methods. And with that together, we have the Synopsys electronic photonic design platform that we called OptoCompiler, which is the industry's only unified electronic and photonic platform. So what is OptoCompiler? OptoCompiler is really supporting design teams and designers to, let's say, increase ease of use, to reduce chances of human error, to shorten turnaround time by providing fast and accurate results. So we target not only photonics experts with this platform, but also the traditional IC designer by unifying the look and feel of the platform, leveraging all the electronics design capabilities from Synopsys for custom and analog mixed signal design, integrating photonic aware layout synthesis in interactive environment with smart productivity improvement features. And this OptoCompiler platform is interoperable with IC Validator for DSC and LVS, is interoperable with electrical and optical or photonic circuit simulators, and that can leverage our device simulation capabilities with Centaurus TCAD and the RSoft photonic device tools. So how does that look like? Well, OptoCompiler is an interactive environment with an EDA-style workflow where you can create a schematic built from a photonic PDK where electrical pins and wires and photonic pins and wires are separately identified, and it's clear for the schematic, let's say, designer what kind of schematic you're building with all your electronics and photonics. And in this environment, photonic connection checks are made to avoid errors of connecting electrical and optical components or pins. On the layout side, several features have been integrated to support curvilinear shapes that are so common in photonic designs, to auto-generate connections between devices following certain design rules and rules for waveguide design, displaying photonic pin properties and making sure that you can only connect waveguides of the same type and only optical connections can be made to optical devices and electrical connections can be made to the electrical parts of either electrical devices or the photonic devices. And then we keep track of, let's say, the layout and the schematic and make sure that when you adjust certain parameters or you make changes in components in the layout, the tool will flag actually a potential mismatch of parameters in the schematic and the layout, and you can override that by back annotating the parameters into the schematic. So with such a schematic-driven layout flow, customers report that they can reduce the turnaround time from their, let's say, scripted environment to this more interactive environment with a factor of 4 to 6. So that's really a big step in productivity improvement. OptoCompiler is also interoperable and therefore provides a complete solution. As Synopsys, we also have these what we call manufacture tools where you develop fabrication processes, you develop your devices that you want to put in a PDK and that are optimized for a particular function or fabrication process. And at Synopsys, we also have tools where we create synthesis, where we do mask synthesis and optical proximity correction, and finally mask data preparation and fracture before you actually create the reticles or the mask files and you go to fab. So there's some features that I like to highlight today. The photonic circuit simulation, where we integrate electronic photonic simulation and analysis, seamless abutment to make sure that photonic ports are really properly connected without gaps or overlaps at any angle, auto-aligning a complete set of devices and components, and assisted waveguide routing. So the photonic circuit simulation really starts with capturing your schematic, setting up simulation and analysis in the OptoCompiler environment, running the OpSim circuit simulator in the background, and analyzing the results of the electrical and optical parts of the circuit. And abutment of photonic ports. So traditionally in an interactive environment, it is pretty hard to make sure that you, even under an angle at 1 nanometer grid resolution, properly attach two waveguide pieces. And we have automated that with seamless abutment in the OptoCompiler platform. Another nice feature that I want to highlight is Photonic Auto Align, where in this case you have a Maxender with all the different pieces, and you can select all the components that you want to connect and align to the origin or to another component. And then by either running a shortcut command or from the menu item, you can automatically connect, rotate in a seamless manner all those devices. Again, all towards increasing productivity for the PIC designer. And finally, some interactive assisted waveguide routing. So this makes use of all the well-known OptoDesigner waveguide routing and connecting capabilities, but now you can interactively interact with it, create keep out zones, move the waveguides in the direction that you want, make changes, and it's also, let's say, automatically adjusted and connected. Again, all to improve ease of use and productivity for photonic IC designers. So we believe that as Synopsys, we really have some great differentiators to enable fast and accurate results. As a vendor, we are unique, having all the TCAD tools for electrical, photonic, and electro-optical devices with Centaurus TCAD and the RSoft device tools. We're able to support photonic layout, curvy designs, but also complex synthesis of lattice filters or arrayed waveguide gratings. We bring a lot of photonic expertise to the table with the largest photonics development and support team, but also already having supported over 1,500 tape outs for photonic ICs. And by bringing all those differentiators and technologies together, we have this OptoCompiler unified platform being part of a bigger tool set with IC Validator, the circuit simulation tools, and the device simulation tools. And we see an increase of 10x to go faster from schematic to layout. And then when you add the integrated design rule checking and LVS capabilities and remove errors early in the design cycle, you can actually go 20x times faster from layout to a verified design that you can submit to a foundry. And finally, by bringing electro-optical or electrophotonic circuit simulation integrated in the cockpit, we can target, let's say, on-target results for multi-wavelength and bidirectional photonic signals right to the designer environment. So what do our customers tell us about what they like about OptoCompiler? Well, one of the customers is reporting that what they really appreciate is that this platform now gives traditional CMOS IC designers the ability to generate photonic ICs in a platform that pretty much looks like and works like a standard CMOS analog mixed signal flow. And the integration of validating that layout and schematic are still the same, either by using this backend notation or layout first schematic, is also reducing a lot of potential errors or findings late in the design cycle. People have been reporting that they could now lay out a chip in a day instead of 2 weeks when writing scripts. So really, what people tell us is that they appreciate the ease of use, bringing together all these key technologies from electronics and photonics in one single platform, using, let's say, industry standards and open standards like open access, Tickle, Python, OptoDesigner, and IPDK. And therefore, they can really remove the need for cobbled together and homegrown tools and flows. So as Synopsys, to conclude, we really believe in photonics everywhere. and therefore we are helping the industry to accelerate adoption of photonics and photonic IC technologies by providing the most efficient platform to design and manufacture photonic ICs. We continue to work together with universities and research consortia to educate the workforce of the future. And we collaborate with foundries and especially the main silicon photonics foundries to develop PDKs to address the need for more volume manufacturing in silicon photonics. So with that, I'm at the end of my presentation about OptoCompiler. If you like, let's say, more information, you can go to our website or you can contact my colleague Nick Nijenhuis, who is responsible for the business development. Thank you.
Thank you very much, Twan. Very nice, clear talk. Once again, I'd like to invite questions from the virtual floor. If there are any, please post them in the chat. Meantime, I have one, well, at least one for you, Twan, and that is in terms of upskilling individuals to use a tool like OptoCompiler, what's the, it might look a bit intimidating to some. What's the kind of level of investment required?
Yeah, so that's an interesting and good question. So actually, and there are two answers. If you look at the traditional IC designers that are active in analog mixed signal and custom design, they really recognize and appreciate all the features of OptoCompiler and are, let's say, quickly up to speed when we train them 1 or 2 days on the specific photonic features and capabilities. So there, the learning curve is really slim. If you look at, let's say, more the traditional PhD style scripting and let's say used designers that are so common in this field, they are quickly up to speed with how to create a schematic and run layout and using some of these automation tools that I just discussed. What they need to adopt to is that certain things that they initially did in their own homegrown or scripting environment, they now need to do in, let's say, an interactive drawing manner, where they can still actually initiate all the scripting capabilities that they used to in the language that they used to. So when there is a PDK, getting people up to speed, we have training programs that last from 2 days, 5 working days, or 8 working days. So that's the kind of training and learning that you need to think about. If you're using a PDK that, let's say, is not provided by the foundry for the OptoCompiler platform, and you're working on in-house PDK development, then we also work with teams to either move them from an existing Opto Designer and OptSim PDK to an OptoCompiler PDK, and we have tooling for that, or we help them by adjusting an existing in-house PDK to OptoCompiler. And again, because OptoCompiler is leveraging some industry standards, there's a lot of tooling and education available to make that transition as seamless as possible.
Okay, great. Thank you for that very comprehensive answer. We have a question from the floor from Pierpaolo Gigino. Can you expand on which foundries are supported or included?
Yeah, so traditionally, as initially Phoenix Software and later Synopsys, we support all, let's say, the active and relevant indium phosphide, silicon photonics, silicon nitride foundries around the world. And so, for instance, Lyonics just presented, and we are a long-standing partner of Lyonics. But similarly for IMEC or Sunny Poly. But the major foundries that I was talking about, so for instance, Tower Semiconductor or Global Foundries, I can talk about in public, are major silicon photonics foundries that we support with this platform.
That's great. Thank you very much. I don't see anything coming back from Pier Paolo, so I assume he's, yeah, that's a thanks. So given that, I just want to ask one last question, which is, I assume that you have some sort of university program with a very substantially discounted pricing. Would that be right to assume?
Yeah, so actually let's say for all the tools within Photonics Solutions, which is the what we call photonic system tools, so simulators targeting photonic systems like radio fiber systems or networks for datacom, either in automotive or in data centers. For the what we call PIC design suite, so this is designing photonic ICs. We have programs in Europe with your practice. For the RSOF photonic device tools, we're actually adding that now to that program. And with OptoCompiler, that we just launched in September, we now also integrating that into the Synopsys University Donation Program. So if universities are interested to get access to our photonic tools, then again, Nick Nijenhuis is the right contact person for that.
Thank you very much, Twan, and thank you once again for a very clear talk.